Okay.
I'm gonna let the cat in real quick.
Okay. We're live, by the way. Well, come in, cat. Come in. Wow, what is that? That's your husband's gaming arcade that he builds, Erin.
Yes.
I remember
You're
you
right,
showed me a
Erin.
video of him making those things. He makes like a desktop version too, right?
He does. I don't know what he does, Derek. It's just all in my basement.
So doesn't he create like isn't it like IoT enabled or something? Isn't it like super high tech arcade desktop gaming thing?
Yeah, so I don't really know. So there's an app and you should be able to connect from the app and then control like from like if you see that like display up there, then you can connect and then you can I think you can file through different images that correspond with the games that you're playing on the computer, but you can also when a game comes up, like if it's Ms. Pac-Man, then the the 80s type display and will come up that correspond with the game. I should know more, but I don't watch any of the videos.
Well, we'll get into the story of how you met Seed. How about that? And then you can tell your story then, and certainly for Mara as well. But first of all, happy Chinese New Year's.
Yes.
Happy Chinese New Year's. I would assume you two aren't necessarily Chinese or Asian, but you work for an Asian organization, so I'm sure they're all like on break, and now you're like working.
Yeah, that's exactly what it is. I was wishing everyone a happy, Chinese New Year last night, but they're all partying and having fun with their families, and then we're here working.
Yes. So we have some co-hosts here, some alumni, some OGs alumni. And we have Tater Tots over here from 2019, Antioch, and we got Nick here. I'll have him introduce himself in a bit. And then Lucian from our old school days. I think you might know. I think you guys have probably met before because Lucian, I think, is familiar with Seed, right? From back in the day when we had our program. So Nick, you go first. Introduce yourself and why you have interest in this particular podcast, and maybe Tots after, and then Lucian. Did Nick freeze on us?
I think he did.
I think it's frozen. Yeah.
Okay, well, Tati.
Hi. My name's Tatiana Lopez. I'm a current junior at Antioch High School with Nicholas Riva, and we were on a team together in 2019 to make an autonomous busing system for our city of Antioch, because our two high schools have different academic academies. So we wanted to open it up and make it so kids could go to both and open up learning experience. And I was just interested in this because I saw some projects, I think, last year, and I thought they were really cool. So I just wanted to see,
You're also in the engineering academy too, right? So you've tinkered with some hardware.
Yeah.
Mm-hmm. Nick, you back yet?
Yes.
Yes, we hear you. Go.
Okay. So my name's Nicholas. I'm a junior at Antioch High. I worked with Tati over the summer of 2019 at the PilotCity internship, and we basically worked on an autonomous vehicle to take kids, or we wanted to have the idea of an autonomous vehicle to take kids from Antioch High School to Deer Valley High School due to the different subjects at each school. So and I was kind of interested in this just to learn, a little bit more fundamental hardware instead of, just having to guess and check everything, maybe get a little more under the belt.
Great. Thank you, Nick. And Lucian, what about yourself? What's up on your side?
I'm a sophomore mechanical engineering student at Cal Maritime in Vallejo. And as far as like my interest in Internet of Things and all that, it's very much like, that's very useful for like going into engineering and stuff like that, because, you put those sensors in bridges, you put those sensors in buildings, and you can kind of get that data back, and you can learn from it, from certain events, on how that it will affect things in the future, as well as maintain things that are already put in place. So I think it's a very useful kind of system of combining things to get the best results and improve the way that things are done. So, yeah.
And you've always been a tinkerer. You're still a tinkerer, right?
Yeah, mostly airsoft guns now. I love they're very mechatronic in their nature, very mechanical, but they have just simple electronics in them that make them just perform really nicely. So that's kind of what I've been playing with lately. But yeah.
All right, cool. Well, I'd like to dive in a little bit with Erin as a start. So we've gotten to know each other for quite a little bit at this point.
5 years.
Yeah, at least 5 years. I think I mentioned this before, but I met the Seed folks when Seed moved into the gate in San Leandro. Yeah, that was it. And then everyone was on 6-month visas. So when I met the first person, I think it was Ming. She had a good relationship. Meng. And we met, and then we, did some stuff together and hung out, and, got some stuff rolling. And then she was gone, right? 6 months went up. And then I think she left to another organization. And then I met some other folks like Ray, right? I think Ray was there for a bit. And then 6 months went away, and then he was gone. And then it was like Zoe, and then, it was always like a cycle. And I even went to Shenzhen, at some point, like I felt connected to all of you, at Seed. And I got to Shenzhen at some point because I was doing some consulting over there, and was able to meet like Violet and hang out with her. And I think Zoe was there too. And even connected, like had Seed do a presentation to some schools in Namsan, the Namsan Education Bureau and stuff. And just always stay connected with Seed. And so you've actually been the most sustainable person I've connected with that Seed. So I feel grateful for that, because it's been a fun partnership with you all. And we always go, whenever we have something that, in our ecosystem of students or schools or whatnot, we're always thinking about, like who's the most, who would be the best resource for this one, right? And with all the Grove sensors and the suite of, tools and, the marketplace and the services you guys have, it's just so robust, right? So tell us about how'd you get into Seed, and maybe even some background on yourself and how you landed in as the head of US.
Okay, so we've known Seed, like my husband and I have known Seed for like maybe after a year or two of them getting started. My husband is a maker, and he's always tinkering with stuff. Like he's always doing some kind of project. And, he's created a business out of it, like a side hustle, like the side business is doing maker stuff. And now like behind me, he's doing all these displays for arcade games, like home arcade games. So I knew them from that. We would meet them at Maker Fair, go out to dinner. And then I started doing some marketing and stuff for them, like 7 or 8 years ago. And then after that, when they started in the US, then when Meng was leaving, then they needed someone to start running the US. And I have like a lot of project management experience from IT. I've been in, the technical space. I've also done sales as well. So it was kind of a good fit, like a merger of like tech and sales. And then that's when it started, like about March 2016, actually.
And what was your career like before Seed? What circumstances did you get connected with, despite just your, husband's connection to Seed and being a tinkerer? Like what was some of the stuff you did before that led you up to this particular position, and your interest in it?
So I used to, I did a lot of like project and program management in the IT space, and I rolled out a lot of different solutions worldwide for some companies that I had worked for in the past. So I had a lot of experience working in the international sphere. I have a lot of experience just working with technical like software in general. And then that does, apply to servers and things like that, which is not necessarily a small single board computer, but it's not a stretch either. And so I've been doing IT for years and years and years. In fact, I was doing IT up until right when I got hired by Seed.
Okay, great. And I do want to also mention to the co-host, if you have a particular question or comment or thought, please unmute yourself and I'll know that you're unmuted and I'll, yield to you. So Lucian, Tati, and Nick. Cool. I mean, that's awesome. And I'd love to have Mario now kind of share a bit about your story on how you got to Seed. And where'd you come from?
Yeah, well, my history is kind of weird with it. I'm from Mexico. Actually, I'm from a little town called Acapulco, Mexico. Then I go to the university to another bigger city called Puebla. And also I've been working around with the Fab Lab community and all the maker stuff and doing some electronic projects around. And then I get involved working in the Fab Lab Puebla. I don't even remember how. I just was a student at university. I studied mechatronic engineering. And then in the university, we was using a lot of the group environment. We used to have a lot of studio kits and stuff. And actually, I used the group sensor just to keep up the components and put it on my boards. Because it was like the easy way for me to understand the electronics. I used to buy things from CS students and stuff just to create my own PCBs. And then doing the Fab Academy, this big movement that is from the MIT and all the stuff, I started working with Oscar, who is one of the heads of the Fab Impact, who is another big Fab Lab in Mexico City, which is the capital here in Mexico. And I don't know, sometimes Oscar was talking with Erin around talking about, I don't remember if an office of the studio in Mexico or just creating a relationship with the studio. But then Oscar just said me, hey, Mario, are you interested to work with the studio? And I was like, why aren't we not interested to work with the studio? I did the interview. I met Erin in the interview. I was pretty nervous. After the interview, I did, well, this is not good enough to get the job. Because, well, the English is not my first language. And then I was not that fluent. I'm not fluent yet, but I think I can do it better than then. And I think that is, after like a month, I just got a message from Erin on LinkedIn. We start talking, then WeChat, and then with the team. And when I know, I was working with CS Studio. I have like a year now. I get the year the last December, and here we are.
Yeah. And by the way, there's a bit of an not echo on your side, but I think because you're in maybe a small environment, so the sound is all reverberating. So it feels like you're like glowing with audio, right? That's kind of how it feels like. So just FYI.
Maybe it's because I have the
microphone. Yeah.
But
maybe
let me switch for the.
Sure.
Yeah.
In the meantime, I'll ask Erin a question because I think it'll pertain to Mario too. So Erin, I feel like the characterization of the Seed community really, like the Seed community is really the heart of Seed, right? What's interesting, it's a Shenzhen-based organization that's overseas, and people typically see China as the manufacturers, and it's certainly the case, right? But Seed has this interesting characteristic, right, of not just being a overseas manufacturer for large organizations and people don't really know what the manufacturer is. Seed's actually a brand, right? In North America, in Europe, and so obviously you're I think I heard your husband was like a blogger for them for a little bit, and he is a maker. And and Mario kind of was used Seed for a little bit. So tell us about the brand and the presence that Seed has in the variety of jurisdictions and countries that you guys serve.
Yeah, we ship worldwide. So we have our customers are all over the globe, and the majority of our customers are actually in the US. And in the beginning, when Seed was just starting out, Eric, our CEO, he'd already worked for Intel. So he'd already worked for a US company, and he was really into the maker movement and facilitating makers to prototype, more effectively. And so what they started doing is they started working with like Make and coming out and doing Maker Faire and just kind of getting the word out about Seed. And the thing about Seed was it wasn't just some kind of run-of-the-mill Chinese manufacturing company where no one spoke English and they only provided documentation in Chinese and then they didn't do any support. Like the idea, because Eric was into the maker movement, the whole idea was to create a community so people could support each other, so that you could provide information so that people could get up and running quickly. And then that means if you're going to do that, you're going to provide support, you're going to provide documentation and things like that. So we were always about the community from the beginning, because I think that is the heart of the maker movement is community.
And that's such a different approach, right, than typical organizations that are based in the manufacturing powerhouse of Shenzhen in China, right? It's people who actually had it. Well, first of all, I think Eric working at Intel sounded like that was helpful to understand the culture of America, for example, or the Americas. But was there something based on your kind of discovery of China's ecosystem and the maker ecosystem and the general manufacturing ecosystem and overseas in general, like what main differentiation do you see in Seed in comparison to other related services or products, right, coming out of Shenzhen or the country even?
Well, Seed is I feel like they have a very Western approach. I mean, yes, they are. I mean, they are a Chinese-based company, and there are certain factors that are just Chinese about them. But I mean, they do have more of a Western approach. They are about like helping out the customer and making sure that everything is on the up and up. Whereas, unfortunately, there are some companies there that aren't like that.
Yeah, for sure. And maybe it's just like the Western approach, right, was really the main source. And Shenzhen has some really interesting things going on too, right? And so I think that kind of merge brings that differentiation out of Seed. So Mario, you came out of actually using Seed, right, when you're in your fab lab locally. So how did you get introduced to Seed and the Seed products, and how's your experience been using it, and why are you a fan of it?
Yeah, well, as Erin said, the environment, the community around Seed Studio have been growing a lot. It's so much easier to use our product from Groove, from, I don't know, maybe the new lines, even the wheel terminal, the Xiao. It's more easy to get involved with electronics than just get out to the market and buy everything that you can get. And that's a fun fact, because even in a university level, even in the master level, you're still trying to use that kind of environments that will help you to save time. That is pretty important in this moment, in this part of we creating electronics, we're doing projects. It's pretty important to know that if you get in trouble, you can get the documentation, you can get forums, you can get people doing things similar with the sensors. And that's pretty important in this time of the electronics and all this area where everyone can just put on the computer and try to build something. And that's why I'm pretty fan of what we're doing, and I'm pretty happy in what I'm doing, because my job is basically help the people with the problems that they have with our products. Even if they have any doubts about how to use the product or what to use in the project, that's my job. No, I can see what they need. I can try to provide recommendations, and I think that's that's the way that I really love what I'm doing here.
Did you use, because it sounds like the main products that kind of launched Seed to become this kind of hardware friendly, kind of tool set that were adopted by people outside of, in the United States, for example, or Europe or whatnot, right? Or Mexico and whatnot, is the friendliness of some of the hardware and the plug and play aspects, right? With some of it. And specifically the Grove sensors, and correct me if I'm wrong, right? Like, was the Grove sensors really the leading product, right, that got Seed to be Seed as a brand? And maybe your perspective coming from Mexico and your Fab Lab ecosystem, is that the case? And I'd love to ask Erin that too. But Mara, why don't you take a stab at that?
Yeah, well, the Grove ecosystems just came to the market to help the makers. That's the way. Because when I was there, I was just starting the university, and it was pretty more simple just to take the sensors and use the Grove ecosystems to get it working. It's more easy than you need to design the sensor, you need to put the sensor in your PCB, you need to create a circuit, print the circuit. It was so much easier to use the Grove ecosystems to build stuff, and even more complex stuff that if you need to invest time to try to learn how to do the things behind. That is pretty important. But in the way of to create ideas, to create prototypes, it's not the only way. I don't know if I can explain the idea.
Sure. Erin, do you have a perspective on that, particularly around the Grove sensors and how Seed kind of caught on fire, in the local maker ecosystem?
Yeah, I think they were a big help. I mean, it is a big help for folks who are interested in kind of, sometimes it's hard when you're doing the breadboarding and you're putting all the jumper wires in, and if you knock something out or you make a mistake, then it will prohibit you from going to the next step. And for some folks, they didn't necessarily want to mess around with that hardware aspect of it. They just wanted to get more into how can I control the sensors? What data can I get? How can I use this data to trigger another, like how can I use the data to trigger like, another output or something like that. So I think it's been very helpful. I mean, that a lot of people like that plug and play aspect of it. And they really liked the simplicity and the drivers being available for Arduino and all that kind of stuff being pre-baked.
Yeah. So give us an overview of Seed. Give us, what is Seed? What services and products do they have? What are some of the lead products? And give us a status of the ecosystem as it currently stands. Give us a baseline.
Okay, so Seed's we've been around for maybe 12 years now, 12 or 13 years. And, we started doing just facilitating easy prototyping. And from there, we realized people were making stuff with our stuff, but they didn't have the ability to do any manufacturing, because a lot of manufacturing facilities everywhere, they want you to do high volume because there's, it doesn't cost as much for everything if you're doing a higher volume. All the manufacturing costs are reduced. So we had customers who didn't have any way to make their products, because normally a small maker who's trying to get started in the business is only going to maybe need like 100, 200, 500, 1,000 boards if they're lucky. So we started doing manufacturing for them because we were already manufacturing our own stuff. So we extended the manufacturing service to our clients. And then from there, we started, consulting with larger companies. We've partnered for years with Google and Microsoft and AWS, creating custom kits for them, for their clients. So their clients could then start to do, making with their platforms, like whether it's connecting to the Google Cloud or to AWS. And then we also then started working with bigger clients, right? So not only are we doing like working with small clients, now we've graduated because we have a bigger presence in the community, and we are making products for corporations. So we've kind of gone from there. And then, and at the same time, we've also been developing our development line. I'm not just adding, like we've added like more industrial sensors now. And then we've also started to add other products that we felt that the ecosystem was missing. Like, for example, last year we came out with Odyssey. It was basically x86 based board because there were needs for x86 based solutions. And there was also a modular approach where we came out with a fairly nice stacking system where people could, do a pre-baked enclosure and kind of build their products on that, because we'd been seeing a lot of customers come to us and basically pretty much trying to do the same thing. I'm going to do A, B, or C, but it really doesn't differ from the past customers. So we wanted to kind of provide a product that would make it easier for people to get going and not have to recreate enclosures, which are expensive, and to just kind of, basically build off of different development boards and using sensors and actuators and already have an enclosure available for them to productize very quickly.
Yeah. So this is what's fascinating about Seed, is that you guys are always ahead of the game and trying to make it as easy and accessible as it can be to build hardware, right? I think that's what it comes down to. So what is the mission of Seed? Like, what do you hear from Eric's mouth and, the leadership's mouth, and always, what are they always repeating and talking about in terms of the goals that Seed has?
Well, I think definitely one of the goals is to make it easier. Let's make it easier to get from a concept to a product. Especially with our Odyssey product line, just, with these extruded metal boxes that can stack on top of each other so that you can add all sorts of capabilities like LTE or Wi-Fi or whatever you need to add to your product, and go from there. And now if the company explodes and they need to move on to a customized mass manufacturing solution, then that's perfect too. We can support that. But let's get people out there in the market and, and putting products in place and not just being stuck in the whole beta test phase. Yeah,
for sure. And you just mentioned, like, I've kind of heard you through different conversation that we've had around your partnerships, right? It's always very impressive to see, the variety of different kits that you have, and the co-branding opportunities in those kits, and the Intel Galileo with the new, Arduino, and you got the Microsoft kit, you got you got all these kits. And then you also, I think you build partnerships with organizations like Twilio or AWS and whatnot to because hardware is complicated, right? For the most part, and you're trying to make it not complicated. So how are the partnerships that you're building helping that mission? Or how, the partnerships that you're building, how does that, serve basically the mission, right, of what you're looking to do ultimately? Like, how does that come together?
So I think it's important that every partnership is like a relationship that you need to nurture. You don't just do one project or help them facilitate like one activity. The idea is to build on that. And I'll give you an example. So a couple of years ago with Twilio and T-Mobile, they joined together and they launched an NB-IoT development board, because T-Mobile was
MB. What's MB?
NB-IoT. It's like when you're sending data, instead of like when you're using your cell phone, you're using LTE solution, but NB-IoT lets you do like smaller chunks of data where you're only sending like little bits of chunks of data. So that's another network that supports that. And you don't need to use an expensive solution like you use for your cell phone. It's basically facilitating IoT communication on a line that doesn't require large amounts of data to be sent back and forth. So with that solution that we helped create, we designed a board. They passed it out at the Twilio conference because Twilio partners with T-Mobile. We started to see people who were, bringing up solutions and prototyping and all this stuff with the development kits. But then we ran into some new problems. Whereas in that time, when you're working with like any kind of carrier like T-Mobile or Verizon or AT&T, there was a very expensive process around getting a board up on their network, right? They don't want to just let anyone put like a communication device on their network without it being vetted. So we ran into a lot of problems where people were prototyping, but they couldn't get to the next level because they didn't have the $20,000 that they needed to certify their board. So over the years, we've been working, especially with T-Mobile, and we've seen their policies change just because of things that, that they've seen and that we've brought up, that where they're like, well, we need a more flexible approach so that people can enable their IoT devices, especially edge devices that are just using, small amounts of data, so that we can have a more connected environment. And obviously that means more money for them. The faster they can get people up and running on their network, the faster they can start collecting money too.
So you essentially hit this point where you're actually enabling people to create not just hardware that's dumb and for your, for your own home or whatever, right? I'm not calling arcade games dumb, by the way, they're cool. But people aren't just making hardware for themselves anymore, right? They're making hardware that actually interacts with and engages with the environment and the people that's looking to serve, right?
Yeah.
So, and you're hitting these walls where now your constituents or your customers are essentially buying these tools, but they're hitting the wall themselves. Like, okay, well, if I'm going to actually make this to a product, I actually need to have partnerships with these organizations or get it certified or get it approved to be on this network, on this particular, platform, right? That I don't control or C doesn't control. So that's where the partnerships come in, right? To enable that future, it seems like. So give a baseline for folks, and Mario, feel free to give your definition as well. What is IoT? What is Internet of Things? Why is it important? And how does Seed, enable that, the creation of IoT?
Okay, IoT is more like a movement, and it has been growing the last few years. And right now it's pretty focused on getting data. Okay, get data from everywhere, from everything. But important thing in IoT is to know what to do with the data. So right now, Seed is creating products that can make the things easier to collect that data. We are creating enclosures, basically, that do the work behind the collecting data for you. And that is pretty great because sometimes getting involved in the programming for do IoT is very complicated. And right now we are making the things easier in a way that you don't need to get worried about how we are going to collect the data, how we are going to, get it in the cloud. We are working on to get that part covered for the people who want to get involved with what to do with the data, what to do with the specific information. For example, I remember with the last case, we talked about creating environment and monitoring systems. I don't know if you remember with.
Mm-hmm.
And the thing is, okay, the idea is great, and maybe get it from scratch is not that simple. IoT is very complex in that way, but we're trying to create the things behind to help the people to create more things, create more innovation without in trouble with the parts behind. And I think that's the great part for all these partnerships, all these movements that are growing, and also are part from the maker ecosystems, and we are helping the people to get involved in these new technologies.
Yeah, absolutely. And so let's get into the project that we're asking from students. Okay. And this, I think, have provided some general good context for everybody on, what is Seed, what's the mission, what kind of products you got, what is IoT, right? So let's talk about the service side, right? So what we're asking from students, and let me give some context, right? So Erin, we've been talking about, our programs together, and we've been patiently just kind of work with each other along the way, right? And we're, we started off with working with some initial kits, right? I think it was the wild links, And then we started working with the smart citizen kits, which went well, by the way. It's just the pandemic kind of threw it all off. But we started working with kits initially, right? But we're getting an issue where when we're working with schools, students are everywhere, especially when in distance learning. You can't get them into one class anymore. So there's an issue of just sheer distribution, right? In the purchasing of the products and getting in the hands, right, of students. So now we're looking at what can we do with Seed that satisfies and satiates and gets students who are engaged with developing their own, right, IoT device, their own PCB board to enable that hardware and that feature, and to have them fully create their own solution and utilize the services, right, and the products and kind of capacities that Seed has, right, to invent and create their own. So our project with Seed this year and maybe into the future as we kind of experiment and iterate towards this is to invent, design, and manufacture your own IoT or Internet of Things hardware product by prototyping your own printed circuit board and maybe more using Seed's Fusion PCB manufacturing service. Now, I could use some slight adjustments to that if that's not what you guys were kind of imagining, because we haven't fully iterated on it yet. So I'll let one of you guys elaborate on and confirm really if this is still the correct direction, and then we can get into Fusion and all that stuff right afterwards.
Yeah, that's the current direction. I mean, that's what we've been talking about.
Cool. So with that, this is very exciting because I brought up a story to you to yourself, Erin. There was a student named Nav from one of our schools, and like midway in the program, like last year, he like DM'd me and was like, "Hey Derek, where's all the hardware?" And what's interesting about that like serious question from this 9th grader, right, was like, there are students who aren't just software people or computer science people, or just people who just can do things all invisibly. There's diehard makers out there, right? And diehard hardware people. And so for this particular project, it's really piquing the interest, right? For those who actually are serious about this space and really love playing and tinkering with real things, right? That they can get their hands on and plug in and, see if the electricity flows through or if the data goes through and whatnot, right? So we're excited about this project because it gives those students, right, a channel to have to learn a lot. First of all, you got to, learn how to probably use, PCB board design software or whatnot. But it allows them to create their own PCB board from scratch, right? So maybe Mario, could you explain your PCB manufacturing service, your Fusion service? Because that's the major service that the students would utilize eventually, right? To essentially create their design PCB board, I'm assuming.
Yeah, of course. Okay, basically we have the Fusion service that have the two main servers, the PCB and the PCAI. One is for assemble and the other is just to create the printing board. The thing here is to know how to design to produce this kind of board, to send your ports to this to the service, to be able to produce your board. And the way to do that is just maybe it's not that easy, but we are trying to make it easy. Okay. There is a lot of software around. There is right now open source and that are helping a lot of these ideas. Also, the open source product or lines are creating amazing such as things because the people are now able to keep creating, to keep working. We are invest big tons of money just to get the software, and now I need to invest a lot of money more to learn how to use it. And the idea with the Fusion service is, okay, you can make your design, you can get your idea, you can design, I don't know, in those online event software to create PCBs. Then you can get something called Gerber files that are basically coordinated because remember we do this This PCB is using CNC machines that basically control numeric machines. So we can create like a space. You can give me these coordinates, and I'm going to pass these coordinates to the machine, and the machine is just going to trace the PCB there. The next step is maybe it's not that simple. The next step to understand, because the next step is the assembly part. C Studio using the Fusion service can get a sample for you. You can give me your design, tell me where are your components, and we can take that and even give you the PCB complete. It will arrive to your home, and you can just do programming stuff, your programming work around. So basically, that's how it works. And I think the interesting part here is try to learn behind how to design for this kind of services.
And what kind of resources do you have available, right, to allow a maker that is more of a newbie, right, or don't know how to do PCB board design even, to start to just, to get them to leapfrog to know how to use it as quick as possible and just to get something out? Because I think the mission here would be to get students to just learn the basics and the critical aspects, get into a software that designs the PCB board, even if it doesn't even work, right? Even if the PCB board doesn't even work, right? As long as they tried and they learned and they just applied it, and then they were to export a file and get it, input it into your seed, Fusion PCB manufacturing service, and just get it printed and get it shipped and just see it, right? Like, tell us about what the simplest path to execution is, so that students, when they join this, they're not saying, oh crap, I have to know how to do all this, I have to know how to, because that won't really work with our program, because we have a bunch of high schoolers in our program who typically aren't trained to learn how to do PCB board design, right? So what advice and resources and recommendations would you have for someone to get started quickly and just leapfrog, right?
Yeah, this is another important part with all the ecosystem that we're creating. We have all the documentation for all our products, almost all our products. So you can go to the wiki or the C Studio wiki, I don't know, search a certain model that you are going to use or you want to use. And we provide even the Eagle designs. So you can download, open in your computer, see what is going on here, and just adapt it to your PCB. Okay, you can take our models that are open source or designs and just apply them to your own PCBs.
Oh, okay.
So that's very important, because even all the maker movement is pretty based on that kind of documentation. Okay, everyone is creating things and uploading all the files, so you can get in home and they say, hey, I'm pretty interested in your project, thank you for the files. You can download them and just replicate it, or even download and adapt it for your project and replicate again. And that's pretty important. I would not say that it's not necessary to learn all the basics and how the current is moving and how the electrons are around the traces and all the impedance works, because you will get in a level that is pretty important to know it. But basically, you can create stuff now. You can get now in your computer for a couple of hours and get a product just to send in and manufacture. And in 3 days, get your PCB and even you solder by yourself or even assemble. And that's pretty interesting, and that's pretty good thing that we created with all these documentation wikis and videos. Right now, we are creating videos on YouTube. So I think that's the part to get in.
Okay, so you just have, well, first of all, Eagle is a PCB board design software.
Yeah.
Correct. And that software isn't necessarily free, I'm assuming.
I think it's open source for students. That's important.
Okay.
It's from Autodesk, and it's Eagle Autodesk, and it's open source for a student.
Oh.
You just need to confirm that you are a student. And there is another alternative that are open and completely free. For example, KitKat and Fritzing, I guess. There's some software that are completely free. but personal, I prefer Eagle because a lot of the manufacturers I created the company for Eagle. Yep. You can even get designs in Eagle from companies more specialized like Texas Instruments, for example. So there is a exponential ecosystem right now with Eagle. So if you ask me where to start, I would say, okay, you need to start from Eagle.
Okay, so and it'd be great to work with you to get the students the resources they need in our program to know which alternatives they can go on to. So they download Eagle, they get an account, and they verify that they're a student. They get that, and then you said that there's also some open source Eagle templates that you guys have that they can download to then open on Eagle to start tinkering with an existing file. Right?
Yeah, right. So you can get existing files for a bunch of things. And even in portal, you can get the schematic files, the board files for determined products. You can just download those files and do whatever you need or whatever you want with those files.
Great.
Obviously, there is maybe a less sciences behind. I don't know. You are not going to produce a million of sensors just to sell it.
Yeah, I would assume that the budgets of these kids, are at the lower end, and I'll definitely get to the question around pricing in a little bit. So they download Eagle. They have a open source files that they can obtain, right? That they can open up those files on the PC on Eagle, tinker with it, learn through the documentation and the wikis and the variety of different resources you have to teach them what certain things are. They're simultaneously have an idea of what they actually want to build, right? And they'll tinker with it from there to kind of iterate as much as they can through the process of just learning by themselves somehow, right? On YouTube, on a Udemy course or whatnot, to get more context of all the gaps that they want to achieve, right? And it seems like a lot of this will be based on the self-reliance, right, on themselves to be determined to learn some of these concepts, right? And then at some point they have a prototype file, right, and they're able to go onto the Seed Fusion PCB manufacturing service website, and then they select a bunch of fields and services and quantities and all this stuff and upload the file, and then you click send, and boom, you pay whatever money it is, and then it comes to your house.
Yeah, basically that's the way, because and even it's right now pretty cheap to buy to build your PCBs. I don't remember. I think it's like a $490 USD, and just to get 10 PCBs for
$4, right? $4 or $5. You said?
Yeah. $5 basically. And yep, basically you can get the design, get to the website, upload your files. You can see your PCB there, how it's going to be done, and then just pay, and in 3-4 days you will get your PCB.
Okay, that sounds easy enough. Okay, I don't know if it's that easy, but it definitely, you're trying to make it easy for people, which is the important part, right? And also you're trying to make it affordable for people too, I would assume, right? I'm assuming shipping costs more than the PCB board itself sometimes.
Yeah. For example, doing this for Mexico, the ship costs around $30. I don't know how much cost is just to United States, but here, yeah, it's more expensive just the shipment than the board.
Okay. Erin, do you want to add anything to this conversation or clarify anything specific or share an opportunity?
Yeah, I mean, I think one of the things that needs to be taken into consideration, if we're just talking about a raw, like a PCB board, like straight PCB, that means no components on it, it's pretty cheap. But the other pricing factor that goes into it is if it is designed with certain components that you're not going to be placing yourself, because soldering, it seems easy, but it's not for some people. Then you would want it pre-populated, like where your PCB would be assembled, like a PCB-A, and then you would have to upload your BOM and stuff like that. That's a bill of materials, which basically lists all the components that you'll be including. And so we do have an open parts list that we have where we source a lot of things from local Shenzhen area. And we keep those in stock so that we buy them in higher quantities so that the cost for those components are actually low compared to if you were just buying, if you're buying onesie twosies, normally it can be more expensive, but because we're buying them in a higher volume, then you can take advantage of that high volume pricing, which makes the cost per component less.
Okay. In this particular scenario, students will probably be manufacturing onesies, right? Maybe twosies. And it just really depends on the parts and components that they're designing with at the end of the day, it seems.
Yeah, that's definitely true. Like if you want a specific, I don't think we're going to get into crystals and stuff like that, but if you want a specific crystal that has a specific, area of measurement, it can be very expensive, but I don't really think we need to worry about that. We're just going to be probably dealing with like some low level components and sensors and stuff like that don't necessarily need to be specific, because the goal of this activity is to learn how to design a board and not measure something within like a certain range of temperature.
Yeah, and maybe we can make it clear for people. Maybe we can all, iterate on this or agree or confirm or whatnot. But essentially what we're asking students is, first of all, we're not expecting them to know how to design a PCB board, right? We're not even expecting them to know how to even, manufacture one for sure, right? Overseas, especially. We're not even expecting them to have money, right? to pay for the board, right? So I think what's interesting here is that we're asking students who potentially are in this program right now and know nothing, right, to be able to just at least start to research the documentation, download a PCB board design software, open up example templates, tinker with it, ask questions on Google, ask questions to the PilotCity community, ask questions to Seed even perhaps, and then be able to actually just learn how to get to the point of knowing how to design something or edit something, right, that's already pre-existingly designed, and then know how to actually put those specifications and upload the file into the Seed, ordering website, and then click order, right, to then essentially get the board. So one last thing that I want to kind of bring up is, how do we expect students to fundraise for this or get money? I would assume, people have, caretakers or parents that they can ask for it. And it certainly isn't a lot of money. If a student, orders a t-shirt somewhere, it's already a lot, that's already the whole cost of everything, right? So we're just going to assume that, students are just going to find some cash somewhere and order it, I guess. Any recommendations, right, where you think how they can get this funded and how much to get funded or fundraised, right?
Right. So we'll definitely be able to provide some coupons and stuff like that so that they don't have to bear the full brunt, but it depends. It's also, I don't want to say it's carte blanche, because if you're picking out specific components that are very costly, then that's, that's we'll have to have a budget. We'll have to have a budget and just see. And then if there is a wide gulf between, the budget and the cost, then we'll have to chat.
Okay. Well, that's very helpful if you can offer coupons.
Yeah.
And we'll definitely have a place for you to insert that so that students, can get access to those. Mario.
Yeah. We're going to see what we can propose. I don't know, maybe we can get like a template to design, and maybe then the students can learn how to build those templates, and after that just try to by yourself to modify that template to get like a specific idea they want to do. So as Erin said, maybe we can get the coupons on those stuff, but I don't know, maybe the students want to add some sensors or some more industrial sensors or more accurate sensors, and that will increment the cost from the the project.
Yeah. So maybe and this may be a conversation offline, but perhaps there's a base coupon for up to this amount, right? And then if they want to add additional things that they want to kind of achieve on their PCB board, they can pay for that essentially, right? Lucian, I think you had a question.
Yeah. So always with prototyping things and creating things, there's always a possibility of someone messing something up, especially we have these students who are very unfamiliar with these systems. I mean, electronics are pretty complex, but like kind of, and this question for Derek kind of as well, but like, is there any kind of like support structure there for these students to make sure that they are like doing things correctly? They are kind of like getting towards their end goal. Because I mean, you can teach yourself a lot, but you probably make mistakes trying to learn all this stuff off the internet. So is there any way you guys are gonna like review what they've done, or somebody's gonna like just look it over, make sure before someone spends money on something that things are probably gonna work, or I don't know, something like that?
Very good question. I'll answer that as like a parameter set because I know how our program works, and then maybe Mario and Erin can share theirs on top. So we anticipate. So our program allows the employer to set up the program once now, and then they produce some content such as this podcast, so that students have all the context and the guidance through the vlogs that we'll have them record as well. And students get to watch that and get direction from the employer on exactly how to get started. Basically everything we're talking about right now would be in some level of detail through the vlogs to some extent. But we do try to remove the employer from the project period during the school year so that their time is optimized. So between February 26, 2021 this year and May 23rd, we want the employer to be generally removed from helping the student at any point, except by answering questions on a peer-to-peer forum that we're going to have for students, right? Now, with that said, I will share that it's probably likely that this particular program will have less students in it because people may not see people don't know not everyone would want to be building their own PCB boards, right, and their own hardware. So because there's a smaller group, there may be possibility, and Mario and Erin might be open to for us communicating with the SEED students specifically, right, and say the 2021 program to actually help, like we can text all them and say, hey, SEED's here to review your PCB board designs, today on April 14th, at 2:30. Feel free to come to our Discord, right, or go on the Zoom, and we'll have Mario there to support you and give you feedback, right? I think that's probably possible, right? And I think Mario and Erin will be willing. But Mario, Erin, any corrections to that or any thoughts to that?
No, I think it's fine. We can do office hours.
Yeah, and actually, we are a community, as Erin said. We have the forums from the studio that is constantly getting feedback from tech support, and actually it's even part of my job to help the people with the trouble they get with the products and them. So I think that's another way to get that kind of help.
Cool. Yeah, I think we can basically, I think as of right now, Lucian, we could probably assemble it on a more ad hoc custom level. And then over time, we'll even be able to give, like maybe next year, we're actually going to be able to kind of iterate on our program template so that's specifically tailored to what SEED can do. So for example, for this project, we may be able to insert an activity where they have access to, email Mario, right, directly. And so that's very easy for us to iterate towards, but our program template is not yet there yet. So we'll do it on a more custom level for 2021, for example. I think what's cool about this is that we can start to iterate towards how do we make this process easy, right, for SEED to offer these services to people who don't know how to even make hardware, right? And what better challenge than having people, who are still learning how to be an adult, right? Learn that process. So I'd like to defer to see if there's any additional questions from our co-hosts here. Tati had to go to class, so that's why she's not here anymore. Nick's probably skipping class.
I don't have I don't have a 12:30 class on Wednesday or Fridays.
You're not credit deficient. That's good. So any questions from you, Nick, on everything you heard here? I'd love to hear how you've digested all this too.
Off the top of my head, I mean, this is all kind of new to me, like, working like PC, like before this, I probably couldn't tell you what a PCB was. So I kind of wanted to come in and learn like what it would be like, see if I'd be interested in, working in this and checking it out. But off the top of my head, no real big questions.
Sure. And I PCB means printed circuit board.
Yeah.
Yeah. I'm very new to it as well, so I'm learning as we're going too. And Lucian, any particular questions on your front, or any comments or digestions or insights that you're getting from this?
I mean, of course, it's all interesting, but I mean, no, not a lot of questions. I think things are covered well. I mean, I kind of hope that some of these, whoever ends up doing it probably has a breadboard or something just to test something, but we'll see how that works out, because all that's expensive. It costs money too. So I'm hoping that someone who's somewhat inclined electrically, because this is some higher level stuff for sure.
Mm-hmm. Yeah. And we also will have more college students in our program now. So we're actually launching into college this year. So there may be some college students join this program too, I would assume. So that definitely changes the skill sets involved with the program as well. I will let each of you, Erin, Mario, any last kind of tips or things that you wanted to cover, but you weren't, there was an opportunity to, anything you'd like to share as to students who are in your program, because this podcast will actually be in your program, so they'll have to watch this to get to the next step. So
yeah, I just think, it's here so that people have an opportunity to learn how to design hardware. I mean, I know that there's not a course around it and it's a little bit self-guided, which can be intimidating, but the whole point is just to get started and have an opportunity to get out there, try it out. If you make a printed circuit board and it comes back and it doesn't work, well, everybody does that. It's not just new people who are just learning this. This happens to professionals all the time as well. So, it's just going through the process, learning the process, becoming familiar with it. It's not, the goal isn't necessarily let's create some, fantastic board that's going to rock everyone's world. It's more about a learning process and engaging in that process and learning. And whether that means that you're going to make mistakes and maybe fail a couple ways along the path, that's fine. I mean, it's a learning experience.
Yeah, it's all a path. And the start here is try to explore the new way to create electronics. And it's impossible not to get lost even for a new path, for a new road. So we are going to try to create a starting point, and then it will be sometimes that the circuits are not going to work, but it's part of the process.
yeah, and what cooler than to have something that you made that's electronic, right? That has like your brand on it, right? Like, and that's and I've been telling Erin this for a while. I want to do a PilotCity like smart city kit, so that citizens and residents can have it'd be really cool if like a lot of different Grove sensors can just plug into it, right? And people really have that malleability, but the software, I would assume, have to be really robust. So we don't have the capacity to do that. So, I'm very curious to know what the students do in this program now and over time, because we want to also participate in doing it too, and not knowing how to do it as well, right? So this is very exciting. Thank you for the opportunity, right, for the students to be able to actually go through this process. I think it really is a nice kind of a win-win scenario. Again, there probably won't be a whole ton of students doing this, like, all those kids who want to do healthcare and want to go flock to Kaiser or something, right? But there's definitely going to be those knobs, right? Or those Lucians, right? That are going to be like, ooh, I want to do a PCB board, So, and that's what the beautiful part is. I think we're going to source those who really would want to do it, right? Even though it might be a smaller program, or it'll take time to build up the program. So thank you so much for all your time, co-host Lucian. Great to see you. Nick, good to see you as always. And I'll have Mario and Erin stick around right after this. So thank you all. That is it.
Nice to meet you guys.
Have a good one, guys.
Yeah, nice to
Bye.
meet you
Thanks
guys
for
too.
joining.